Of illustration, let's say that there's some function j of w that you want to minimize, and maybe that function looks like this. To make this easier to draw, I'm going to ignore b for now, just to make this a one-dimensional plot instead of a higher-dimensional plot. So gradient descent does this. We're going to repeatedly carry out the following update. I'm going to take the value of w and update it. I'm going to use colon equals to represent updating w. So set w to w minus alpha times, and this is a derivative, d of jw dw. And we'll repeatedly do that until the algorithm converges. So a couple points in the notation. Alpha here is the learning rate and controls how big a step we take on each iteration of gradient descent. We'll talk later about some ways for choosing the learning rate alpha. And second, this quantity here, this is a derivative. This is basically the update or the change you want to make to the parameters w. When we start to write code to implement gradient descent, we're going to use the convention that the variable name in our code dw will be used to represent this derivative term. So when you write code, you write something like w equals or colon equals w minus alpha times dw. So we use dw to be the variable name to represent this derivative term. Now let's just make sure that this gradient descent update makes sense. Let's say that w was over here, so you're at this point on the cost function j of w. Remember that the definition of a derivative is the slope of a function at the point. So the slope of a function is really, the height divided by the width, right, of a little triangle here, this tangent to j of w at that point. And so here, the derivative is positive. W gets updated as w minus a learning rate times the derivative. The derivative is positive, and so you end up subtracting from w. So you end up taking a step to the left. And so gradient descent would make your algorithm slowly decrease the parameter if you had started off with this large value of w. As another example, if w was over here, then at this point, the slope here, or dj dw, will be negative. And so the gradient descent update would subtract alpha times a negative number, and so end up slowly increasing w. So you end up making w bigger and bigger with successive iterations of gradient descent, so that hopefully, whether you initialize on the left or on the right, gradient descent will move you towards this global minimum here.